So in lesson 3.3, we're going to review some slope that you've already learned in Algebra 1. So we have our slope formula here. Slope is rise over run. So we have the difference of our rise, which is our y values, and then we have the difference of our x's, which is our run. So let's take a look at these four types of slope that we have. Here we're going up from left to right, kind of like we're climbing a mountain there. This is a positive slope. We have here like we're sliding down the slide. So this is a negative slope. Here we have a slope we're not going anywhere, we're just hanging out. That is 0. And here, we're falling, so we can't even stay up there, and it is undefined. All right, so now we're going to identify the slope using these lines over here. So line AB, that would be a slope of 0. Line AC, so let's go ahead and count. We're going down 1, 2, 3, 4, 5, and then going right 1, 2, 3, 4, 5, 6. So negative, because we went down 5, right 6, negative 5, 6. AD, we are so steep we're falling off of it. So undefined. Okay, CD, I'm going up 1 and right 6. 1, 2, 3, 4, 5, 6. So up 1, right 6. So now we're going to go ahead and we could plot these points and then do the same thing of counting, or we can use our formula that's up here where we subtract our y's and subtract our x's. Make sure that your y's are on top. Your x's are on the bottom. You can label them if you need to. X's come first, then y, and then you can plug them in. So we're going to subtract our x's. It doesn't matter which direction you go as long as you go the same direction both times. So if you want to subtract the first y and then the second y, that's fine, but make sure you subtract the first x and then the second x. That same order on the bottom. Okay? So you can do 6 minus 5, and then you can do 3 minus negative 2. Watch double negatives because we have the minus sign in a part of our formula and the negative. So that's just going to change it to a positive there. So 1/5 is our slope on that one. This next one, let's go ahead and do our y's, and you can kind of do it kind of vertically and then subtract, but make sure again that your x's are on the top there. So your y's are on the top and your rise, and then your run, your x's are on the bottom, and then subtract down there. So 2 minus 0 is 2, and then negative 4 minus 7 is negative 11. So we have negative 2 over 11, which the negative can go out front or it can go with the top or the bottom, but only one of them, only one negative needs to be present. So next we're going to look at this graph here, and we are going to identify basically our slope here. So it looks like Justin is driving from home to his college dormitory at 4 p.m. He is 260 miles from home. At 7, he's 455. So we want to figure out, well, rise is going to be his distance here. So from 260 to 455, we need to find that difference. And then we have our hours here, our x from 4 to 7, so 3 hours. And that is going to give us 195 for our 3 hours. And then if you are able to reduce it, go ahead and try and reduce it if possible. It looks like we get 65 miles per hour for every 1 hour. Okay? Right, let's take a look next at parallel and perpendicular. So parallel is going to be lines that never touch. We've talked about that before. And we have perpendicular, we know that. That's where they form a right angle. Now their product, if we multiply our two perpendicular, is going to be -1 when we multiply the two slopes. Vertical and horizontal lines are perpendicular to each other, form that right angle. So if a line has a slope of A over B, then the slope that's perpendicular, well, what we want to do is the opposite reciprocal. So that means that we're going to see if this is 4, this is negative 1/4, we flip it and we change its sign to be the opposite sign. So this would be flipping it, B over A, and we make it opposite. Since this is positive, we make that one negative. Now, parallel, for this one, we just keep it the same. So it's just going to be the same, A over B. So these, A over B and negative B over A, those are again called opposite reciprocals, or perpendicular slopes, but opposite reciprocals. So let's go ahead and graph these two lines and then see if they are parallel, perpendicular, or neither. Okay? So go ahead and plot 0, 2, label it U. Plot negative 1, negative 1, label it V. Using a straight edge, go ahead and draw a line through those 2 points. And next, for XY, we're going to go to 3, 1, and then negative 3, positive 3. And then draw a line through those 2 points. And just for confirmation, let's go ahead and find our slopes here. This slope is down 1, and then right, well, we're going to have to reduce it. So let's, all right, so I had to adjust my point here to make sure it was at negative 3, 3. So we're actually going down 2 and right 1, 2, 3, 4, 5, 6. So down 2 over 6 is negative 1/3, which is our line XY. And then let's find our line UV's slope so we can compare it. So we are going up 1, 2, 3, and over 1. 3 over 1, which is 3. So 3 and negative 1/3, those are opposite reciprocals. So this would be perpendicular. So we can definitely see it, but we want to double check with our slopes to confirm. All right, so go ahead and try this one. Graph GH's line and graph IJ's line, and then look at their slopes, and then double check, push play, and check when you're ready. All right, so for the slope for GH, rise 4 over 4, that's 1, reduces 2. This one you're going to go down 8 and right 4, which is negative 2. So those are actually neither. They are not the same, and they are not opposite reciprocals. So they are neither. All right, let's take a look at this last one. We're going to graph our line 5, 1, label it Q. And we want a line that contains that point that's going to be parallel to MN. Well, let's figure out what MN slope is, and then we can go ahead and use that point to go through it. So here we're going to go negative 2, 4, and then we're going to go 2, 1. So this line is going to have a slope, if we're counting here, 1, 2, 3, down 3, and over 1, 2, 3, 4. So negative 3/4 is our slope for MN. So we want this to have the same slope. So we're going to go down from this point Q down 1, 2, 3 over 1, 2, 3, 4. And we're going to go ahead and draw our line through that point. And there we go. Now we have a line that's parallel to MN. So flipping to this next page, we're going to look at these lines and compare and see if they are parallel, intersecting, or coinciding. So the difference is parallel have the same slope, but they have different y-intercepts, so they're not the exact same line. These lines don't have different, they have different slopes, and they're different. They just intersect. There's no relationship really beyond that. And then coinciding is the exact same line, one line right on top of the other line. So they have the same slope, but they also have the same y-intercept. So sometimes those can be accidentally labeled as parallel, so we need to make sure that we identify those as coinciding. So here, 3 and -3, well, those are different slopes, so this one's just going to be intersecting. Those are definitely not opposite reciprocals, and they're not the same. So next one, we got to change this. It looks like we need to get y, finish getting y alone, divide by 6. So y equals, let's reduce this to -1/3 x plus 2. And now let's go ahead and look. Well, this is -1/3, this is -1/3, but these are different. So that means that these are two different lines, but they have the same slope. So that would be parallel. And then we need to change this one and actually change this one. So let's go ahead and add 4x. And then we're going to, looks like divide by 2. So this line is y equals 2x plus 8. So there's one of our lines. And then this line, it looks like we need to distribute, and then we'll go ahead and add 10 to finish getting y alone so we can see what it looks like in slope-intercept form. So 2x plus 8. So this is the same slope and the same y-intercept. So that means that these are the same lines, so they are coinciding. All right, in this last little table, we're going to fill in what would be the slope that's parallel and what would be a slope that's perpendicular. So if the slope's 7 parallel, it would be 7. Perpendicular, we need to flip it and change its sign. So it becomes 1/7 and it becomes negative. 6 parallel would be the same. Again, flip it, change its sign. So go ahead and try those and then check when you're ready. All right, double check that you have the same slope for the parallel column and you have perpendicular, you flipped it and changed its sign.